Hey everybody, it's Dr. Kalanicky. So this is our practice test for Unit 3. It's exactly how your test is going to be set up, except obviously the numbers will be very different. So we're testing on two different standards. Number 5 is add, subtract, factor, and expand linear expressions. Yeah, that's all one standard. And number 6, we're starting to, and we have been continuing to translate word problems into equations and inequalities. We haven't gotten to equations and inequalities yet, but we're working on expressions right now, which we're basically almost at equations, and that will be our next unit. So this is a little pre-test on those topics. All right, so our level 2 questions. Let's start off with number 1, which says, which pair of expressions represents like terms? Oh, I gotta change my pens again. They did not save, and I particularly like blue pens. Here we go. So which ones are like terms? Remember that word like terms means they have the same variable and the same exponent. Actually, I'm going to write it in red so you can see it. Variable and the same exponent. So the only ones that have those same variables and the same exponents, not the same variable. This one doesn't have a variable, this one does. This one has a variable, this one doesn't. Is letter A. They both have the variable x, and they have different coefficients, but that's okay. 5x and 2x are like terms. Number 2, when distributed, and that's one of our words, distributed correctly, this expression, -5 parentheses 3x plus 6, is equivalent or equal to which of these expressions down here? So now distribute means to multiply. So I need to multiply this -5 by everything inside the parentheses, and what we do to show that is we're showing it with these little arrows to show that I have to not only multiply -5 by 3x, but I also have to multiply -5 by positive 6. When I do that, -5 times 3 makes -15x. And -5 times positive 6 makes a -30. And the only one that has that is this guy right here. Ooh, really careful, because that one says plus 30, this one says minus 30. This one's the right one, letter B. All right, pause the video if you need to, but we're moving on. Number 3, when factored correctly, 12x minus 18 is equivalent to. So this is very similar to what we just did, except it is the complete opposite. Factoring means to divide. So I need to divide this so that it is equal to one of these expressions. Now, you have a couple different strategies here. Since I give you the options, you can always distribute these answers and see if one of them matches 12x minus 18. That's one strategy, which you could totally do. I am going to factor it. I left the room down here because when we factored, we would write the expression here, and then we would draw a nice fraction division bar over it, and then we have to decide what number that can divide into 12 and 18. If you're using your multiplication chart, look down a row that has 12 and 18 in it, and that will be a number that will divide 12 and 18. And that number happens to be, there's a couple numbers, but 6 happens to be one of those numbers. 3 is another number, but we'll talk about why that might not be that's not the biggest number, and we want to use the biggest number all the time when we're factoring in order to factor completely. Now that I chose 6, 12 times what makes, 6 times what makes 12? 2. And I have to leave the x there. And 6 times what makes -8? That would be a -3. Now, some very tricky answers in here. Letter D looks like 2x minus 3. Well, that's what I wrote. But is 2x minus 3 equal to what I started with? It's not. The only thing that's equal is if I write this expression, but I also include the number that I divided out, which is why letter A is actually the right choice. Because if I distribute this, 6 times 2x is 12x. 6 times -3 is -18. I know that's the right answer. Next one says, circle the like terms in the following expression. Again, like terms, I'm looking for letters that have the same variable and the same exponent. These guys don't. So there's only these two right here. These constants by themselves are like terms. I can actually add them together. Because this is a number and this is a number, and I can always add numbers together. So that was a little bit of a tricky question, but I liked it. All right, moving on. Simplify by combining like terms. All right, same thing. When we did this, I used highlighters just because I like the ease of seeing the highlighter. So 5a, is there anything alike with 5a? Yes. 5a is alike with positive 4a. Remember, we circled the symbol as well because that will help me in adding. And then I'm going to use my same old rules. Same signs, add. Ooh, bad handwriting. Different signs, subtract. Remember, we talk about these rules all the time when I'm adding. So 5 and 4 are same signs, so I'm going to add them to get 9. I'm going to put the a next to it, and then 2 is all by itself, which is okay. It has no like terms. So my final answer is 9a plus 2. Moving over to the next question, I'm looking for something that's alike with negative 8c, and that would be positive 12c. And then 3 is all by himself, which is okay. Again, looking at my rules, these are different signs, so I'm going to subtract them. 12 minus 8 will get me 4. And my 4 will be positive because 12 has the larger value. And then I'm just going to leave the 3 alone. Number 6 gets into that translating. 5 more than a number can be expressed as. So obviously my expression is going to have 5 and it's going to have a number. And when we mean a number, and if we don't know what it's called, we can call it x. We can call it any letter we want, but in this case they used the letter x. So the question is, what operation is 5 more than x? Well, more than just means add, which is why x plus 5 will be your answer. All right, moving on. Next one, Dean bought 12 Rubik's Cubes that cost the same amount each. Underline or circle any keywords to help you determine the operation. Then write an expression that represents Dean's total bill. So a couple different ways to write this. I just thought of this. I see the word total, which tells me one operation. But then I also see the word each, which also means another operation. So he bought 12 Rubik's Cubes, but the cost is the same amount each. The only problem is I don't know how much they cost. So I'm going to use the letter C for cost. And since each Rubik's Cube costs the same amount, I would take the letter C for cost and multiply it by 12. That's one way to do it. This would tell me how much all 12 Rubik's Cube cost if I do 12 times whatever the cost is. The other way to do it, since we're talking about total, which means to add, so I would literally have to write 1 Rubik's Cube cost, 2 Rubik's Cubes cost, 3 Rubik's Cubes cost, 4. I would have to go all the way to 12, which was a little crazy to do. So really 12C is the shortest way to show the total amount that these 12 exact same Rubik's Cubes are going to cost if he buys all 12 of them. All right, next one. Simplify each expression. So again, we're simplifying, which really just means we're going to combine any like terms that we see. Get out my highlighter. 3 is like with the other constant, which is positive 10. So when I add them, same signs add, I'm going to get 13. And then I continue looking through the problem, anything I didn't use yet, and I see 2 more like terms, positive 5x and negative 6x. When I combine those different signs, subtract, I will get negative 1x. Now I could write it 2 different ways. I could write it, I tend to write the x with the variable in the front, and this would be plus 13. Notice how they're almost exactly the same. I literally just switch the pieces around. I prefer it this way, I think, but this way is also correct. Moving on to my next problem, I see negative 6 and I see another constant, negative 12. So I'm going to add those two like terms together. These are same signs, so I'm going to add. Remember, we have to constantly go back to those rules, and if you need to write those rules down, same signs add, different signs subtract, and go right ahead. You can always write them on your test if you need to, because I constantly say these two rules. So these are same signs, so I'm going to add them, and I'm going to get negative 18. And then this negative 2y is all by itself, so I'm just going to stick it right at the end, and there we go. Same thing, I could have switched the order around. It could have said negative 2y minus 18, but it's about the same. Alright, now we're getting a little more challenging. Adding polynomials. This is really the same thing we've been doing, combining like terms. Now we're adding. Again, we talked about these parentheses really don't need to be there because I'm just adding. But I want to add this whole thing with this whole thing, and all I can do is add the like terms. Even though they're in parentheses, I can only add this 4 with this 3. I cannot add 4 and 2a because they are not like terms. So let's add these same signs. I'm going to add, I'm going to get 7. Now I'm going to look for 2 more like terms. I got 2a and negative 7a. Again, highlighting the symbol in front of my coefficient to help me with the adding. So a negative 7 and a positive 2, those are different signs. I'm going to subtract them. My answer will be negative 5a. There we go. Over here, same thing. I'm looking for like terms. This, I'm going to circle that positive to go with it, even though I know it's a positive 5, but just to remind me, I'm going to highlight that positive sign as well. Negative 3 plus positive 5, different sign subtract, gets me 2. And then going back with my highlighter or my circling to circle the other 2 like terms, negative 12w plus 6w will get me different signs. I have to subtract them. My answer will be negative 6w. All right, getting better with my handwriting over here. Now, when we get to subtraction, we have to remember when we subtract to use our rule. When we are subtracting, subtracting is the same thing as adding the inverse. So we use the rule LCI, leave change inverse. So I first, before I even look at like terms, I have to rewrite this as an adding problem. So I'm going to do that with my typing feature right here. So this says negative 4a minus 6. Leave that whole thing alone. And if you want to, you can even put in the parentheses. Change the minus sign to a plus sign. And then I want the opposite of 3a plus 2. So that would mean negative 3a minus 2. And there we go. Now that I use leave change inverse, I can now leave change. And remember, when you inverse this whole part, both terms, or any terms that are in that one. Now that this is an adding problem, I can use my same signs add, different signs subtract rule and combine the like terms. Negative 4a, negative 3a together makes same signs add, negative 7a. The other 2 like terms in here, negative 6 and a negative 2, those are also same signs add. I will get negative 8. So yes, you will have to do this on your test. Adding, you do not. You just combine the like terms. Subtracting, just like we've been doing this whole year so far. If I see subtraction problem, I rewrite it as an adding problem first, adding the inverse or adding the opposite when I am subtracting. So same thing over here. Before I start, I'm going to rewrite this as an adding problem. 2x minus 9, I leave that part alone. I change the subtraction to addition, and then I take the inverse of negative 6x plus 7, which would be positive 6x minus 7. Make that a little bigger for you. There we go. Again, I use my rules, leave, change, inverse. Now that I've done that, I can now combine the like terms. Positive 2x and a positive, I'll highlight that positive sign just in case we forget, positive 6x. 6 plus 2 makes 8x. And then again, same signs over here, negative 9 and a negative 7, which would combine or add to make negative 16. And there we go. Cool. Subtracting, a little bit harder than adding, just one extra step, that leave, change, inverse step. All right, two more. Again, back to factoring and distributing, except this time we do not have any multiple choices, so you just have to factor it and distribute it yourself. Excuse me. All right, so here we go. Again, factor means divide. Distribute is its opposite, means multiply. So I have to divide something into 18 and 4. Again, if you're using your multiplication table, you want to look across a row and find a row that has 18 and 4 in it. So what is one number that has 18 and 4 as its multiples? The only one I can think of is 2. So now 18 divided by 2 makes 9. And I put the x in. I bring the subtraction sign up. 4 divided by 2 makes 2. Now, our last step, super important. This 9x minus 2 is not my answer. To factor it completely, to show the factoring, whatever I write has to be equal to 18x minus 4. And 9x and 18x are not the same thing. So here is my final answer. 2 parentheses 9x minus 2. This whole expression, this is my answer, this blue expression. This is equal to 18x minus 4. So when you are on your test, make sure that you include the 2. Has to go in there. Otherwise, what you're writing has to be equal to 18x minus 4. All right, I'm going to do the same thing over here. 9x plus 5. Again, I'm going to divide that because that's what factoring means, to divide it. What number goes into 9 and 15? If you found it, it should be 3. 3 times what makes 9? 3 times 3. X is going to make 9x. And 3 times what makes 15? It's going to be positive 3 times 5. And again, my final step is taking those two pieces, the number I divided and the quotient, and putting, plus, and putting them together. This whole thing, 3 parentheses 3x plus 5 is my final answer. So again, factoring means to divide. Distributing means multiply. And I have to multiply this negative 5 by both terms on the inside of those parentheses because I want negative 5 of 2x plus 3, not just negative 5 of 2x. So I'm multiplying negative 5 times 2x, and that gets me 5 times 2 makes 10x, and it's going to be negative. Negative 5 times positive 3 makes a negative 15. And I will tell you this, what I'm boxing out right now, is equal to this expression right there. Same steps. This time I don't have any negatives. 5 times x and 5 times negative 6. 5 times x is just 5x. I love that one. If you need to, and you weren't sure, remember that hidden 1 inside. Ooh, terrible. Let's try that again. Remember, there's a hidden 1 next to that x. Ooh, still terrible. That's okay. 5 times 1x makes 5x. That's why it is 5. 5 times negative 6 is negative 30, and I am done. Final two questions. Again, we're talking about translating. I want you to write an expression, which means what you're going to write has numbers and letters and probably signs or symbols in it as well. So let's see. Sam ordered 3 t-shirts on Amazon. That cost $T each. The t-shirts, you ordered 3 t-shirts. They each cost $T. And then Amazon charged them $4.50 for shipping. Ugh, I hate shipping. I prefer Amazon Prime. But I have to write an expression. So if she ordered 3 t-shirts and they each cost $T, that means 3T. I would take the price that I'm paying for the t-shirts and multiply it by 3 because I'm buying 3 t-shirts. And then Amazon's charging me $4.50. So I want to know her total bill. I'm going to have to add on that $4.50 to get her total bill. Now I can't do anything else with these because these two terms are not like terms, so I'm done. This is it. I use multiplying, 3 with a T next to it to show multiplying because of the clue word each. Each shirt costs the same amount, so I would have had to add this $T shirt plus this $T shirt plus this $T shirt, and the faster way to doing that is just saying 3 times T. And then again, something is added to my bill, shipping, and I want to know the total. Total does mean to add, so I have to add up what the t-shirts cost plus the shipping charge. Next question says, Sam bought 8 pairs of headphones for their class that cost H dollars each. So again, headphones cost H dollars. I'm buying 8 of them, so I'm going to use 8 H's. Sorry for the terrible handwriting. 8 pairs of headphones cost H dollars each. She also bought 5 whiteboards. We need some extra whiteboards. And the whiteboards cost W dollars each. And since they bought both of them, the headphones and the whiteboards, I obviously need to add those two together to find her total bill. I can't do anything with these two. I'm going to retype them just because I hate how they look right now. I can't do anything with these two because these two are not like terms. So that is my final answer, 8H plus 5W. I hope this practice test helped you a lot, and good luck on your test soon. Bye, guys.